Hello and welcome to this technical demonstration of TC15. Hello, my name's Jason Gledhill from K Systems. I'm joined today by Richard Hunter and Patrick Aldridge. Today we are going to demonstrate the installation of our EWI system. First of all, we need to identify the substrate. Then we need to carry out a pull-out test into the substrate. That will determine the fixing type required to install the system. The next stage is to check the building for line and level. Any deviations must be corrected before the installation can commence. The next stage of the process is to prepare the substrate. First of all, we apply Algae Clean. This is a liquid spray applied product which is sprayed directly onto the surface of the wall, which kills any mould growth. Secondly, we apply R7 bonding agent, and this will kill any suction and allow the render to suitably adhere to the wall. The next stage is to fit the base profile. When insulation is required below DPC, XPS board may be fitted in this zone. Compriband seal tape is then fitted to the top edge of the XPS board prior to the fitting of the base profile. The base profile is fitted line and level at DPC. If no DPC exists, then the base profile is fitted at 150mm above ground level. The base profile is fixed with hammer set fixings which are installed at 300mm centres. The base profile is jointed with connector clips and cut and mitered at external corners to ensure good detailing is achieved. A clip-on bead is then finally fitted with a mesh up stand prior to the fitting of the insulation board. We're now ready to start fitting the insulation boards. First of all, we need to fit Compriband seal tape to all the abutments.
The reason why I'm installing the Compriband seal tape about 4 or 5mm behind the pencil line is because when I offer up my mineral fibre and install the fixing, that will compress the mineral fibre in and should end up in line with the pencil line.
Cut sections of insulation must be no less than 200mm in width. The insulation boards are mechanically fixed with the specified fixings, including an oversized washer. The insulation boards are aligned in a brick bond fashion. L-shaped sections of insulation are fitted around all structural openings.
I've just made a small loop 20mm back from the end of the junction in the Compriband seal tape. That allows me, when I make two junctions and I compress the insulation to the window reveal, it will compress the junction and bind them together.
Okay, so we've got the insulation fitted now. So first of all, I'm going to talk to you about the boards. These are a mineral wool board. They are A1 fire rated. They are a dual density board, which means the face is very firm and the rear of the board is soft. The way we know that is because the boards are lettered, and this is done by the manufacturer to make sure they're installed. As you can see, it says this side up on the board. The boards are arranged in a brick bond fashion. As you can see, the boards are staggered and we've got a half overlap on each board. We don't want any less than 200mm in overlap, but we generally go for a half board overlap, which is 600mm. Around the windows, we have L-shaped sections of board. This gives us additional strength because this is a weak point in the building, and it's also a wind-loaded zone because of the opening and the vortexes on the external corners. In addition to the L-shaped sections, we stagger the boards on the external corners. As you can see, they're interlocked as we build. This is because of the wind loading on the external corners, and it gives additional strength. So here we have an oversized washer and a central fixing. The fixing goes through the washer and then a hole is drilled into the wall and the fixing's anchored into the building. We use an oversized washer because of the mineral wool and the nature of the material. The material is very soft and it can easily pull over the fixing head. So this is why we have the oversized washer to accommodate that. So now we've got all the insulation works complete, one thing we must do is protect all the surrounding interfaces, i.e. windows, soffits and anything else that is prone to being splashed by render during application. Once we have all this in situ, we're good to go. So now we're ready for the base coat. The HP14 base coat is supplied in 25 kilo bags. It's marked with a batch number and date of manufacture. The product must be used 12 months from this date and stored in dry conditions. The material is mechanically mixed with 6 litres of clean water for 5 minutes minimum. It is then left to stand for 5 minutes. It is then reworked and ready for application. Stage 1. Fit the corner beads embedded into the wet material, line and level. The material is applied at 4 to 6 millimeters thick. The material is then serrated vertically using a notched rule or trowel. The mesh is laid vertically into the top third of the wet material. All joints in the mesh must be overlapped by 100 millimeters minimum. Stress patches must be fitted at all structural openings, and these are 500 millimeters long by 250 millimeters wide.
Okay, so we've applied our HP14 and we've notched it. We've put our mesh on, and as you can see here, I've extended the mesh right to the point of the angle bead on the head and down the side of the reveal. And the reason why I do that is if you install the mesh just behind the plastic in this location, vertically or horizontally, there's always the possibility that this small area here will have no mesh, and if the stress patch is fitted in the wrong area, there's the possibility that it could crack.
Fixings are then installed through the mesh at 1 metre centres while the material is still wet. Once the fixings are installed, 100 by 100 millimetre mesh patches are placed over the fixing heads and then trowelled onto the same plane as the primary mesh. The material is then allowed to cure for 24 hours in favourable weather conditions. The first stage of the base coat and mesh application is now complete. As you can see, the material has been serrated and the mesh has been laid onto the top third of the wet material. The mesh has been suitably overlapped vertically at 100 millimeters, and stress patches have been applied at the structural openings. Those are 500 long by 250 wide. It's crucial the stress patch is fitted diagonally and it hits this point. If it's fitted any higher, this area is then susceptible to cracking. Another key point when installing the fixings through the mesh is that the fixing head is covered with render and the mesh patch, and it is pushed onto the same plane as the primary mesh. This again is important to achieve good flatness within the system. Now this stage is completed, we can move on to the slurry coat. Apply the material to the cured base coat at 2 to 3 millimeters thick. Level and flatten the material using a spatula. The material can then be finished by either one of the two options. Option 1, finish with a sponge float in a circular motion to produce a flat finish. Option 2, finish with a spatula and then remove any trowel lines with a rasp once the product is cured, typically 24 hours in favourable weather conditions. So now we've completed the slurry coat, and as you can see, the wall's looking nice and flat. It's important that the wall's flat because we don't want any undulations showing through on the finished surface. We've used two different methods of application. We've used the sponge method here, and on this area we've used the spatula and rasp method. Both methods produce a flat surface, which again is very important for the top coat. The particle size on the top coat is typically 1.5 mil, so it will show through if there's any undulations in the base coat. Again, really important that this is checked for flatness prior to moving to the next stage. Once this is checked, we're ready to go to the primer and top coat stage. The TC primer is supplied in 15 kilogram tubs. It's marked with a batch number and a date of manufacture, and it also has a 12-month shelf life. The primer must be mixed before use, and a small amount of water may be added to improve the workability. The primer is then applied by roller or brush, ensuring the entire area is covered, including all edges. The primer must then be left to cure until touch dry. Once the primer is cured, the top coat can be applied. The Silicone TC is supplied in 25 kilogram tubs. It's marked with a batch number and date of manufacture. It has a 12-month shelf life from date of manufacture. The Silicone TC must be mixed before use, and a small amount of water may be added to improve the workability. During periods of cold, humid weather, TC additive can be added to the Silicone TC to speed up the curing process and eliminate the risk of wash off. The Silicone TC is applied to the wall at a depth of the grain, typically 1.5 millimeters, and then any excess material is removed. The Silicone TC is then rolled in a circular motion with a plastic float, and any excess material is removed. Once the excess material is removed, then a final pass is required to achieve the desired finish. The final stage of the system is now complete, and as you can see, the Silicone TC has been applied to the wall. If we look closely at the wall, we can see that the material has been applied to the correct depth of 1.5 millimeters, and it's been finished to a good standard, nice and flat with an even dispersion of grain across the facade. If we look at the detailing at the external angles, we can see that these are nice and crisp, and they've been formed nice and sharp with a nice clean iris, which is what we like to see. Once the product is fully cured, we can then remove the protective film from the windows and other interfacers, and then we can apply a mastic sealant to these areas. Once we have completed this, the system is finished and can be handed over to the client for inspection.